Okay, so here's a problem to help you with the trig and vector unit extension problem. We have three forces all acting on the same object with different magnitudes and different angles. And we want to determine what is the resultant of these three forces. So the first thing we're going to do is draw a free body diagram. I'm going to draw x and y axes to help us with the angles, and then we can jot these forces in. So the first force is acting with a magnitude of 70 pounds in the direction of negative 60 degrees from the positive x-axis. So I'm going to open that angle up, negative 60 degrees right there. But really all I'm interested in is the fact that that angle, that reference angle right there, is 60 degrees. And I'm going to sketch in the horizontal and the vertical components of this force. So going over to the right there and then down. And I know that the magnitude of this force was 70 pounds, so I can label that as the hypotenuse. Now, just like on the hanging hippo problem, we are going to break this up into vertical and horizontal components. So that vertical component, I'm going to label that as negative 70 times the sine of 60, and the horizontal component there I will label as 70 cosine of 60. I also could have used negative 60 inside of my trig functions, and what you know from even and odd functions, would have ended up at the same spot. So I'm going to choose to do this problem only using reference angles, and so I will be applying some negatives to some functions, but that's okay. You could not use the negatives and then just add everything and keep the angles as they are, negative 60 and then the other ones as well, 120 and 45. So that's my first one. Let's do my second one. The second force has a 45-degree angle and a 40-pound magnitude. So I'm going to open this angle up in 45 degrees right there. And then I would probably normally break up the horizontal and vertical like this, except for writing over ourselves. So instead, I'm just going to do it the other way. I'm going up there and then over there. Notice there shouldn't be any difference between that. If that angle right there is 45 degrees, we know that this angle in here is also 45 degrees, and so we're going to get 45 times the cosine of, oh wait, what is that? That should be 40 times the cosine of 45 because the magnitude there that was given to us was 40. And then for this vertical component, we're going to have 40 sine 45. And now let's sketch that last one in 60-pound magnitude and an angle of 120 degrees from the positive x-axis. That's going to give us this angle going up right there. And bring this down, use reference angles. I know that that angle then has to be 60 if that whole angle right there is 120. So I have that 60, and now I'm going to split this up again. The magnitude of the vectors there was 60 pounds as well. So I'm going to get 60, I'm going to get 60 times the cosine of 60 for the horizontal component, but I'm going to make it negative since we're going out to the left there where x values are negative. If you wanted to, you could have, again, used 120 instead of 60, and then you wouldn't need that negative there, but that's okay. And then I'm going to go 60 times the sine of 60 for that positive vertical component. So now I have all of my vectors there, and I want to figure out what is the resultant of this, and so I need to add all of the like components. I need to add all the vertical components, and I need to add all the horizontal components. So I'm going to do that real quick. So when we add up the vertical components and then we add up the horizontal components, we get these two values, 19.624 and 33.284. So that is corresponding to our resultant vector with the horizontal component of 33.284 and the vertical component of 19.624. And we want to know a couple things about that. We want to know in what direction is that vector heading, so what is the angle it makes with the positive x-axis, and also what is its magnitude. So a little Pythagorean theorem and then a little inverse tangent. So let's figure out the magnitude first. If we want to know the magnitude of this vector, remember we're dealing with a horizontal component, a vertical component, and the magnitude is essentially the hypotenuse of a right triangle. You can think of it that way. So a little Pythagorean theorem, to find this magnitude, we're going to take the square root of 33.284 squared plus 19.624 squared, and that will equal the magnitude of this resultant vector. So, crunch that in your calculator. You should end up with roughly 38.639 pounds as the magnitude of the resultant vector. And now we want to figure out what is the angle, the direction angle of this vector. So think about what we know. We know that if we're orienting everything with the positive x-axis, we've got some positive horizontal component going out 33 out this way, and then some angle going up from there, some side, some angle, blah, 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 19.624 right there. And then this vector is, again, the hypotenuse, if you think of that as a right triangle. So we want to know what is that angle right there, and to find that we need to use some inverse tangent because we have an opposite side and an adjacent side. So we're going to say that the tan inverse of the opposite side, 19.624, divided by the adjacent side, 33.284, will tell us that direction angle. And if you do so, you should end up with an angle of roughly 30.523 degrees. And so we know our magnitude and we know our direction.